Here is a stoichiometry example from the WebAssign. So we're going to take a close look at it and see if we can learn something from it. So here we go. We have 15.4 grams of the second reactant, and the second reactant in this case is NH3. So we're going to be working with NH3 to solve both of these problems. So we'll use 15.4 grams of NH3 to find the SI3N4, which is one line of stoichiometry. And then to do the H2, you again start with NH3, and then you'll go to the H2, another line of stoichiometry. And some parts are the same, so it's good to write it out so you have the same parts and you can easily pull them back up again. So we'll start with 15.4 grams of the second reactant, which is NH3. I'm probably going to run out of room squeezing it in here. And we're going to have 3 lines. You always do this if you're going grams to grams. The very end is going to be grams up at the top, but it's going to be the grams of the thing you're trying to find, which in this case is not the dog, is the SI3N4. And down here is 1 mole, and it's also the SI3N4. I'm going to totally run out of room. But here, I'm going to go grams to moles, and that's always 1. And that one is the NH3. I'm just repeating grams of NH3 from there to there so I can cross-cancel them out. If I have moles of SI3N4 down there, then it must have come from up there. So I'm going to write moles of SI3N4, which you won't be able to see on there. And if I have moles of NH3 here, then down here I must have moles of NH3. I'm getting sniffed out by my dog. This is disgusting. And so the only numbers I really need to find are, I have to add up the molar mass for NH3, which I did that is about 17.03. I did that by adding up 1 N and 3 H's from the periodic table. Then over here I need to add up 3 SI's and 4 N's. It took me a while because I got the numbers all wrong, working in the dark with a dog eating my socks. I think that's 140.31. I know you can't see that 3-1 there. And then the last thing I have to do is the mole proportion or the mole ratio here between NH3 and SI3N4. Well, I get that from the equation, and I need to balance it. I forgot to balance it. So if you spend time balancing it, there's a 3 in front of that one, a 4 in front of that one, a 1 that we don't usually write for that one. That's my cat talking to the dog. And I believe in front of this one is a 12. Totally strange. So, you're getting it all tonight. For my NH3, the number is 4. So I'm going to put a 4 there. And for the SI3 thing, it is a 1. So I'm going to write a 1. And now I'm going to do my math. I'm going to do 15.4 divided by 17.03 divided by 4 times the 140.31. Let's write that 3-1 in there now that I managed to change colors. And bada boom, bada bing, I think you get 31.7 grams of that really weird SI3N4. I would never ask a question with this SI stuff in here. That's totally weird. So that is the answer for that one. Now let me see if I can clear this off somehow or another. Eraser, mate. Eraser, eraser, eraser. There we go. Get rid of that. More getting rid of. More getting rid of. Get rid of me. Get rid of me. Yes. Maybe we can just go to the eraser. Get rid of me. 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 And get rid of me. Now we'll start over and work for the H2, but we still start again with the 15 0.4 grams of the second reactant, which is NH3. NH3, try to squeeze all in here. And again, we'll have 3 lines. Here's the exact same stuff as we had before. So 1 mole of the NH3, which I'm not going to squeeze in there, 17.03 grams of the NH3. And here again, we'll have the moles of NH3 that we got from the balanced equation. And I'm looking at that, and again, that's 4. So we'll write a 4 in there. And here we'll go to the moles of the next thing we're trying to find, H2. I'll go back and look at my H2, and the number in front of there is 12. So I have 12, and over here I write 1 mole of H2, and up here I write the grams, which I think is 2.016. Did that one off the top of my head. And I do not have the answer for this one, but you go 15.4 divided by 17.03 times 12 divided by 4 times 2.016. And it should give you grams of the H2. And I'm guessing 15 divided by 17 is less than 1, and that's 3 times 2 is 6, divided by less than 1, so it's probably around 6 somewhere. That's my guess. Oh, it tells you the answer right there, 5.47, haha, and I did get that other one, 31.7. Duh, Miss A, the answer was right there. Anyway, I hope this little tutorial on how to do the stoichiometry helped. It is always a repeating pattern. You write what you're given, you change it to moles, you do the mole ratio from the equation, those are just the coefficients, and then you change back to grams. And make sure that one's always 1 and that one's 1. This number has nothing to do with the number in front of it from the equation, because if you used 12 times that, you'd have to have a 12 down there, which is the same proportion as that. I hope this helps you out. Good night.